In this video, we will be coding programming exercise 2.10, the end of chapter 2. So let's get started. The first thing we're going to do is create a class. So we'll go to File, New, and Class. We're going to remove the package so that we're going to use the default package. And our class will be PE02_10. We're going to allow Eclipse to go ahead and put in our main method declaration, and we'll click Finish. All right, and so here we are. First thing we want to do is go ahead, of course, and remove this auto-generated stub since it does us absolutely no good. And then I'm going to go in and comment at the end of these curly braces. This is the end of my main method, and these curly braces denote the end of my class. So I'm going to end PE02_10. All right, and now, again, every program we start with our comments. I'm going to use the block comments, open that with a /*, and Eclipse, when I hit return, will automatically give me a line to start writing my comments that begins with an asterisk. It will close that block at the asterisk and the /. And we know that the first line of those comments, you must put your name, and then I ask that you put your W number. I ask that you put the section and class, so 160, let's be better, CMPS 161 - and then XX, where XX is your section number, and finally the date. All right, once we have that, we need to also comment the purpose of the program. And so if we go into chapter 2, again, this is programming exercise 10 at the end of the chapter. And so we'll see that it asks us to write a program that calculates the energy needed to heat water from an initial temperature to a final temperature. Your program should prompt the user to enter the amount of water in kilograms and the initial and final temperatures of the water. They give us the formula to compute the energy, which is Q = M times final temperature minus initial temperature times 4184. M is the weight of the water in kilograms. The initial and final temperatures are in degrees Celsius, and energy, Q, is measured in joules. So let's go ahead and write that up as this program. Remember, we talked about when we tell other programmers or our future self what this code does. We want to start with this program and then describe it from there. So I'm going to use the magic of copy and paste. To do this, this program calculates the energy needed to heat water from an initial temperature to a final temperature. The user will enter the amount of water in kilograms and the initial and final temperatures of the water. I give the formula, and I tell what the various variables mean, giving the units of measure. And then initially, the book provides us with a sample run. They tell us that if we allow for 55 kilograms of water with an initial temperature of 3.5 degrees Celsius to and reach a final temperature of 10.5 degrees Celsius, then 1625484.0 joules is needed, or 1,625,484.0 joules is needed. So when we look at this program, the first thing that I want us to notice is that we're getting user input, and we know that anytime we require user input, we must use the scanner. And we talked about 5 things that we needed to do, minimally 5 things, in order to have a scanner. So let's go ahead and code that in as some comments to ourselves to help us in our programming. So we know that the first thing we do before we even enter that class block is we have to import the scanner. And then we know that everything else will happen within inside the main menu, the main method, the Go square, where Java will begin processing. So in that main method, we know that we have to instantiate or create a scanner object. And we know that we're also going to need to prompt the user. And here we're going to prompt the user for the amount of water in kilograms. And then we know that we need to read in the data from the user. The next thing that we'll need to do is get more information from the user. We'll need to get the initial temperature from the user. So we'll prompt the user for the initial temperature. And that's going to be in degrees Celsius. And then, of course, we have to read in that data. There's another piece of information that we need to get from the user, and that would be the final temperature. So we're going to prompt the user for the final temperature. Of course, in degrees Celsius again. And read in that data. And there's one single computation that we must make. So once we've read in all the data, now we're ready to go ahead and do that computation. And the computation is we need to determine, using the formula that was given, the energy, or Q, required, the energy in joules. So we're going to compute energy in joules. And then once we've done the computation, we need to report our results to the user. So we report the results. And so we have essentially completed the task at hand. That is the algorithm to complete the task at hand. But we know before we end our program, because we were using a scanner, the last thing that we need to make sure that we do is close that scanner. And so that is our algorithm for solving the problem at hand. So let's get started coding. Now that we've written the algorithm, the next step, of course, is we're going to go back and actually write the Java code to do just this. So when we import the scanner, again, that happens outside of our class, and we use an import statement. So import java.util.scanner. And that is, of course, an explicit import. We are explicitly importing the scanner class and only the scanner class. Remember, we talked about implicit import versus explicit import. The implicit import would have had an asterisk or bang instead of scanner, and that would import all of the classes in the java.util package. But we're choosing instead explicit import, because the only one that we need is the scanner. And so we're going to explicitly import just that class. Okay, so following along in our algorithm, the next thing we need to do is to instantiate a new scanner object, or to create a new scanner object that we're going to be able to use in this program to read in that user input. And so we say scanner, and then we need to give our scanner a name. Remember, the book generally will name the scanner input. That's not the only name available. We can name the scanner anything we want. And so I like to name my scanner Jeeves. So the name of my scanner is Jeeves. And then the rest of that says I must use the equal sign, the keyword new, and then scanner system in. And so I have now created, I have now created a scanner object. The name of that scanner is Jeeves, and Jeeves is ready to go to work and get some input, read in some input for me. So the first thing that I want to do is I want to read in the amount of water in kilograms, and I want to read that in from the user. So of course I have to prompt the user, or I have to tell the user what information I want from them. Otherwise they just have a cursor blinking at them, which is ambiguous, which gives them absolutely no information. So anytime we want something from the user, we first prompt them and ask them for the information that we want. It's always good to give them the units of measure so that they know exactly what unit of measure their input is expected. So when we prompt the user, we always want to use our system.out.print or system.out.println statement to do so. So system. And of course, we're going to ask them a question, so it's going to be exactly as displayed in between these quotation marks is what will appear on the console. So we say, enter the amount of water in kilograms. And that will prompt them for the piece of information that we want. Now we're ready to read in the data from the user. So when we read in information or data from the user, we're going to have to store that somewhere, and we're going to store that in a variable. We are going to store that actually in a double, because we anticipate that it's possible that they may in fact have a decimal value in this amount of water. So we're going to say, hey computer, give me some memory enough to store a double in there, and I'm going to call that memory, or that block of memory, that location mass. And into that memory location, I want you to assign the value, and the value that's going to be assigned is that value that the user just entered. So I go and get it. And in order to go get that information from the user, I've got to put Jeeves to work. So I say, hey Jeeves, I call him by name, and then I use the dot notation, and then I use next double. Next double has a pair of parentheses, or a set of parentheses with nothing in it. There's no parameter in the method next double. And then of course this is a statement, so I use my statement terminator. So essentially I'm allocating some memory, creating this variable mass, naming that memory mass, and into that I'm having Jeeves go and get me the next double from the user. The next thing that I need to do once I have that information is prompt the user for the initial temperature in Celsius. So again, my system.out.println. So I'm asking for the initial temperature in degrees Celsius, and I have to go get that piece of data. So once again, I need a new variable, a double, and I'm going to call it initial temperature using my camel case. And into that, I need to send Jeeves to go get the next double that the user inputs. It's important to notice that even though I'm getting multiple pieces of information or multiple pieces of data from the user, I only use one scanner to do it. Jeeves is capable to do many jobs, or do the same job multiple times, if you will. He's able to get multiple pieces of information for me. I do not need multiple scanners. I have only one single scanner named Jeeves that is able to read in multiple pieces of data from the user. So now I have those two pieces of information from the user. The last piece I need is the final temperature. So I prompt the user. and then I read in the data. Again, I'm sending Jeeves to read in the data. First, I have to consider where I'm going to put this data, this piece of information when I get it, and I'm going to put it in a double, and I'm going to name that double final temperature. I'm going to send Jeeves to go get the next double. So at this point, I have all of my pieces of information that I need, and I'm ready to do my computation. Now you're going to notice on the left, we've got all of these little yellow warning signs is exactly what that is. It's not a syntax error, but it's a warning sign. And what it's telling us, if we click on it now, is that the value of the local variable final temperature is not used. So it's just alerting us to the fact that, hey, we've declared this variable, we've assigned it a value even, and we're not using it anywhere in our program. And what you're going to see is that once we do this computation and actually use that variable, all of these little warning signs are going to go away. So once again, these are not errors. They're not the red X's that we normally see when we have some type of a syntax error. They're actually just warnings to alert us to something that we need to be aware of. Okay, so now we're ready to compute the energy in joules. So we're going to use the formula that was provided. And we're going to store this information in a double that I'm going to call energy. And into that double, into energy, I'm going to store the result of the computation. And using that formula, the computation is mass times, the asterisk is the times, open parentheses, final temperature minus initial temperature. Times 4,184. So we take the mass times the final temperature minus the initial temperature times 484. It's important to notice that we have to enclose final temperature minus initial temperature in parentheses. Otherwise, we would end up doing the multiplication first for the subtraction because of the order of operations, as we talked about in a previous lecture. And so now that we've done the computation, what we'll need to do is go ahead and report those results to the user. And when we report the results to the user, this is a form of output. This is something that's going to be displayed on the screen, and the only way that we can do that is using our print statement. And so we're going to tell them that the energy needed is, I'm going to put that space there, and then I want to actually report the value that is stored in the variable energy. And so in order to do that, remember, I can't use quotation marks. I have to send the computer to go and retrieve that information. And so I'll use my concatenation operator, the plus sign, and then I simply say energy, the name of the variable, the name of the location where it's stored. And that will say, hey, computer, go to that memory location, that mailbox, if you will, get the information that's in there and print it out to the console. And then the only thing left is to close the scanner. And so when I close the scanner, I essentially send Jeeves home. His work is done. So Jeeves.close. And that's it. That's our program. So let's run it. And we'll run it using the sample data that was provided in the textbook. So to run, we're going to go up here to run, or we could click this green circle with the white arrow in it, either way. It's going to ask us to enter the amount of water in kilograms. We're going to enter 55.5 kilograms and hit enter. The initial temperature in degrees Celsius is 3.5 degrees Celsius. The final temperature in degrees Celsius, 10.5 degrees Celsius. And remember, we expect 1,625,484 joules to be the answer. So let's see if we got the correct answer. And indeed we did, 1,625,484. And so there you have it.